Well, you can open your eyes again, but let's have a look. Okay, here's your lake. Winter temperature 12 degrees Celsius. And we're talking about late winter, okay? Because there's a delay between the heat flux and the response that you get. Anyway, that's just the detail. So late winter 12 degrees Celsius, late summer 26 degrees Celsius. Okay, assume no zero salinity changes, and that's what you can do in your imagination. You can just switch off. It doesn't have to happen all at the same time. Just imagine it's only temperature change. And that's how it looks like in your TS diagram. So I switch on the pointer, and you essentially move into summer, warming, and then you move into winter, cooling, and so on. Move up and down. And that repeats and repeats and repeats. And this is for a closed seasonal heat flux cycle. That means the annual average is 0. Just for simplicity. Okay. That's the first bit. Okay. And this is what you can see in the Adelaide coastal waters. You get a warming, cooling, warming, cooling. Okay? All right. So what happens now with the salinity? Let's have a look at salinity. What influences salinity? What changes the salinity? And the first thing we have to look at is evaporation and precipitation. And this is from an older paper here, measurements of the seasonal cycle of evaporation and precipitation. So the one with the filled symbols, the black symbols, is evaporation, and what it is, the unit is millimeters, okay, per month. So you have 25 centimeters per month in December. So and then you have it drops to 20 centimeters, and so on, 10 centimeters, and then you have the lowest evaporation in winter months, and then it goes back up to high values. The symbols with the open symbols is precipitation. These are here 3 different stations, but what you can see is that you get maximum precipitation during the winter month, and just going a little bit higher at some stations, exceeding the evaporation. So overall, you have the dominance of evaporation. Okay, and you can sort of estimate that over a year, you would get a loss of, you lose 1 meter of water. Okay, so you lose 1 meter of water. And so what happens then with the salinity? If you lose water, you lose the fresh water, the salt stays behind, and the salinity, the salt concentration, increase. So to illustrate what happens now, you can again look at a closed hypersaline lake. So you have a lake with seawater in it. Yeah. You start with that and you evaporate. What evaporation does, it removes fresh water, the water level drops, and the salt concentration increases. Okay, and shown here is the sequence of 3 years. Year 1, year 2, year 3. In a TS diagram, what you can see is that the salinity increases. Sorry about this. Try to get the pointer going. Yep, here. Yeah, in 1 year, salinity increases, and then in the second year, salinity increases, and so on. It's not a closed cycle. However, this is a closed lake. Gulf St. Vincent is not a lake. So in these hypersaline lakes, what's the final state is indeed you get a salt lake. No water, just the salt left behind. Okay? All right, so that's the key. So now in your imagination, you have to work out how do you balance salinity, because you've seen in the measurements that the salinity goes back. Okay, there's a decrease. Increase, all right, increase is easy. And just have a look before we go to the final stage of the interpretation. We just go back 1 slide and look at the seasonal cycle again. Seasonal cycle of evaporation which is this top curve, okay? And you can see that the maximum evaporation is over the summer months, January, February, March, okay? You have, and December as well, and then you have low values during winter. You also have to take this seasonal cycle into consideration. Okay, so let's go to the final step of the interpretation.